Third time's a charm. So I've caused worse outages than myself at work, so this is fine. And now for our final keynote speaker of the conference, LizFong-Jones. As a bit of an aside, as followers of Liz on social media will know, she's had something of an odyssey over the last couple of days, having to fly from Sydney to the west coast of USA to get some urgent documents notarized, then getting back on a plane to Sydney, returning yesterday morning. Anyway, it all seems to be sorted now. About Liz. Liz is a developer advocate, labour and ethics organiser, and site reliability engineer with 16 plus years of experience. She's an advocate at Honeycomb for SRE and observability communities, and previously was an SRE working on projects ranging from the Google Cloud Load Balancer to Google Flights. Liz will be talking about cultivating production excellence. Over to you, Liz.
Good day, everyone, and thank you for joining me. I wanted to acknowledge that I am living on the lands of the Gadigal people, and I also wanted to acknowledge that there are things happening in the world right now, and that Tonga is under threat from climate change and from the volcano that has just erupted. Okay, let us go ahead and begin. So today I'm really excited to be telling you about all of the lessons I've learned from the past 15 years of my experience working in the field of site reliability engineering at companies large and small, and how we can take those lessons and make our workplaces more humane for us and to make our systems more operable and reliable. So those of us who are attending LCA are very familiar with the idea of operating in production. But some of our colleagues may not necessarily have that same notion. So to get everyone on the same page, we have to orient around what the objectives are of the business, what the objectives are of the code that we are writing. And fundamentally, we're writing code in order to solve problems, but the problem is that just landing the code in the main branch of Git does not necessarily mean that your job is done. That there are so many additional steps that you have to complete in order to make sure that your services are delivering value to end users. Because if your change has to be repeatedly rolled back, or it takes months to push out, you're not actually delivering that value until months later. Another challenge that we frequently encounter is that production is increasingly complex. That we have all of these challenges of scale and reliability needs and feature needs, and we've developed these layers of infrastructure to try to make it easier. But we've also made it hard to fit that all into the head of one individual person. That with microservices, the theory was that we could decouple our services from each other and decouple the release and launch cycles so that each team could ship independently. But that now means that a service 3 layers away from you can break you in a way that you didn't anticipate, in a way that was not a failure mode of a more tightly coupled system. We also have problems with big data, where big data can result in increasing demands upon compute and networking, and we have to be able to scale our systems to meet and address that demand. So some of the systems that we're creating add complexity in order to try to solve some of these challenges. But when the systems don't work exactly as planned, for instance, as the audio feed this morning did not necessarily work, right? It takes a substantial amount of effort to try to figure out what's going on and how do we fix it. So that's what the subject of today's talk is. How do we fix our problems with more confidence more quickly? But let's start with defining what the problem is. What does uptime mean? When I was a Wii game developer, when I was about 16 or 17 years old, I worked at a small game studio, and we had the database, and we had the game world server. And if those were up, everything was fine, but if they were not up, everything was 100% down. But that's no longer the world we live in today, where you may have hundreds or thousands of Linux servers that are running as VMs on Amazon's infrastructure, or on Azure, or on GCP. And we can't wait until our customers complain to us and ring us up on the phone and say, I'd like to cancel my subscription, right? Like, we would like to be a little bit more proactive at detecting when our customers are having problems without necessarily getting paged every single time a single server flaps. So there are all of these demands for reliability, for features, and for investment in future scalability. It's a lot to deal with. And honestly, as someone who has been in the role of a hero in an organization, who's the one person holding up the reliability on her shoulders, it doesn't work. Not for a decade, 2 decades. You get really tired. So what strategies can we employ in order to make our services more reliable and friendlier for the people? So as Miles introduced me, yes, hi, my name is Liz, and I'm a principal developer advocate at Honeycomb. And Honeycomb is a company that aims to help make developers happier and more productive through improving observability into production. So here are some of the lessons I've learned from both working with Honeycomb's clients, as well as in my previous life at Google on the customer reliability engineering team, as well as on various other SRE teams at Google. The lesson that I learned is that heroism doesn't work, and that we need different strategies. And that those strategies cannot necessarily just be buying tools and to fix things. And I know that this is ironic because I do work at a company that sells developer tooling. And here I am telling you, don't buy DevOps, right? Why is that? The answer is that when you have all of these technologies that you're trying to integrate together, that you're trying to make work together, sometimes you're adding to your workload rather than reducing your workload when you actually try to glom on all these things that are supposed to make your developers' lives easier. For instance, you get told to write more tests, but what happens if you add more tests and add more tests and add more tests, and they start flaking all the time? And then people ignore the red build because, oh, that's just flaky tests. I'm just going to merge anyways, right? Congratulations, you've just made your problem harder, not easier. Or let's talk about the drive recently to kind of encourage people to push to production quickly, recklessly almost, right? What happens if your continuous integration and continuous delivery that's meant to ship shit fast ships shit fast? Oops. Or those of us who have been around the community for a long time, you've probably run rm-rf/ a couple of times before. Right now, imagine doing that to your entire production infrastructure. Well, congratulations, you can do that now with infrastructure as code. You can delete your entire production infrastructure with one stray commit. Oops. Or let's talk about Kubernetes. Not everyone needs Kubernetes. It's a lot of complexity, and it's only worth it to solve certain problems. But the number one thing that I see people getting wrong is adopting the idea of production ownership, or let's put everyone into PagerDuty. And I think that that can have some negative side effects. Let's talk about them. When you put everyone on call for systems that they are not prepared to run, right? Those of us who have scar tissue from years and years of being around production, we can handle, to an extent, being paged at 3 a.m. But let's suppose you're a brand new engineer, and your first experience with on-call is being paged at 1 a.m., 2 a.m., 3 a.m., multiple times per week. And you eventually are going to say, take me out of this on-call rotation, or I quit, right? It's not a happy situation if you have a system that is continuously generating noise. And even when you do try to debug it, you don't know heads from tails. Where do I get started? And if you have dashboards, those dashboards are often a source of technical debt in and of themselves, because they're chasing your last outage. They're, 20 different graphs on 20 different pages, and you're trying to figure out which line wiggled the same line as this other line, right? Like, this isn't actually helping you solve the problem. All that's happening is you're spending time in a state of cognitive overload while your customers are suffering and incidents are taking forever to fix. So finally, you pick up the phone and you call someone like me or like Miles, and we, tell you, oh, you just frob the thing, restart it, it'll be fine in the morning, right? Except for someone like me or Miles, we've gotten really tired of getting woken up every single week, at least once a week, even if we're not on call for years on end. And finally, you go back to sleep, you wake up in the morning, cup of coffee in the hand, and you realize that you can't actually push fix because someone has broken the build overnight. And even though each individual set of unit tests passes, the integration tests don't, because there is a problem in the gaps between our services that is causing things to flake. So this is what we describe in the field of site reliability engineering as a state of operational overload, where there's no time to do projects, and even if you did have time to do projects, there's really not much of a plan of how do I get myself out of this situation? How do I spend 1 or 2 spare hours in order to chip away at this pile of technical and operational debt? So this can feel very, very draining. This can feel stressful, right? Like many of us have been here. And it can feel like you're barely hanging on to the edge of the cliff with your fingernails. So how do we make this better? What are we missing? And why is it that tools don't help? Well, I think the thing that we need to focus on is that people are the ones who operate your systems, that you cannot have a healthy system without healthy people standing behind it. For instance, let's take me as an example. Every single time, I've probably given this talk several dozen times now. Every time I go through this section, my heart rate goes up, right? Like I have all of that packed up anxiety about production outages of getting paged at 3 a.m. And it gets really challenging, right? But I need to take a moment and focus on me. I encourage you to focus on yourself, right? Like to take care of your needs. In my case, I'm going to take a deep breath. I'm going to take a drink of water. And that will help me deliver a better talk. In the same way, you should make sure to take a deep breath, everything's going to be fine, and drink water even when you're in the middle of an outage. Focus on the people first. So much better, right? So you cannot run a healthy system without healthy people. And that means that tools cannot fix a culture if your people are not healthy, right? That your tools can help automate processes that you already are inclined to do, but it can't fix a culture where people are blamed, where people are on call all the time and stressed out, right? Like tooling that generates more alerts is not going to be helpful there. So what should we do instead? I argue that we should invest in people, culture, and process. That investing in those 3 things is how we get out of this mess of operational overload and production pain. This is what I call production excellence. The idea that our systems should be more reliable and friendlier. That we shouldn't have to feed computers with the blood and sweat of human beings. That we have to plan intentionally and figure out how are we getting there, what milestones are we aiming for, and what key performance indicators are we measuring. We also have to think about getting the right set of people into the room. And this means a lot of the people who should be in this room are not necessarily in this room, even at LCA. That we need to involve everyone from the business level to the support teams, right? We need to involve people who are even in sales, right? Like we need to involve people all across the spectrum in order to make sure that we're aligned about delivering value to customers in a sustainable fashion. So that means that we need a psychologically safe environment, that people need to be able to contribute, and that if you cannot feel safe to contribute, none of the rest of this talk is going to make sense. But let's talk about the 4 key elements of production excellence that will make your life easier. First of all, in order to operate an excellent system, you need to know when that system is too broken, when it's outside of the bounds of the normal expected system behavior. Secondly, you need to be able to debug those failures in order to restore them to working order. Third, you have to be able to collaborate across multiple teams in order to solve these problems that cross multiple microservices. And then fourth and finally, you need to close that feedback loop. We don't live in the world of Groundhog Day. It's not okay to repeat the same outages over and over. So we need that feedback loop to solve the longer running issues that we face as engineers. So if you do those 4 things, you'll have a system that is much friendlier to your human beings who are operating the system. So why did I say no one our systems are failing too much, right? Why did I not say no one our systems are failing at all? The answer is that if you got alerted every single time a packet dropped in the fiber optic channel between here and LA, right? Like you'd get paged all the time, right? Our systems are always failing in small microscopic ways, but we build redundancy into our systems in order to try to solve those problems. So instead of thinking about, are the systems failing at all, right? Like, is the lawn outside on the domain outside where I am, right? Like, is every single blade of grass on that lawn green? No. But overall, does it look green enough? Yes, right? Like, it's soft, it's lush, I can go lie down and have a picnic, right? Like, that I think is good enough. So instead of saying, is the system failing at all, we need to talk about, is the system failing too much? And that means we need a quantitative measure of that we can use to operate the system. This is the idea from site reliability engineering at Google, the idea of the service level indicator and its companion, the service level objective. A service level indicator and service level objective, what they represent is a common language between us as engineers, our business stakeholders, and our customers about what the expected level of reliability is for our services. And we need to think about our services in terms of the broader context. What is it that our customers are trying to achieve? What is that critical user journey that people are trying to do? For instance, maybe it's people buying tickets to attend the outdoor film festival in Sydney. Or maybe it's someone who is trying to place an order for computer parts from Scorptech, right? Either way, there's some action that a customer is trying to achieve, and we need to make sure that we're measuring it to ensure that it is of a satisfactory level of performance and quality. So we need to understand, is a given interaction between our customers and ourselves creating a good or bad experience for that customer? How do you know? Well, this is where product managers and user experience researchers and customer success can really help you out to help you understand what differentiates a successful from a failing transaction. Or if you work in a field where you are able to experiment on your own systems and where you use those systems yourselves, my main piece of advice is to do chaos engineering, to deliberately slow down transactions so you can understand where does it start to feel sluggish, and then set your threshold just shy of there. Because our goal is to give machines rules for deciding whether customers are having a good or bad experience. And sure, we're all used to trans-Pacific latency, but we can in general say, hey, a request is successful if it responds in, maybe not 100 milliseconds, but 300 milliseconds, right? That's fast enough. And that it has to return a success. It can't return a fast fail is not a success to us as a customer. And then we can think about what's the total denominator, right? How many eligible events did we see? How many transactions were attempted? And I don't just mean just take everything that comes into your load balancer, because there's often health check traffic, there's often denial of service attack traffic, right? We need to think only about the real customer traffic, not synthetic events. And then we can compute our actual achieved availability, the number of good events divided by the number of eligible events. And we can set a target that we can measure, that is our service level objective. So the service level indicator earlier helped separate good events from bad events, but the service level objective helps us decide over a longer period of time what percentage of the events in the SLI should be successful. So for instance, if the website that I'm operating was 100% down today, but I came to you and said, but tomorrow we're going to be 100% up, you'd laugh at me, right? So it turns out that human beings have memories longer than a day. So you need to think about measuring reliability and setting goals for it over a longer period, like 30 or 90 days. We also need to set an appropriate target percentage. For instance, I might aim to have 99.9% of events be successful over the past 30 days, where an event is successful if it was served in less than 300 milliseconds and with an HTTP response code of 200. So why did I not say aim for 99.99999? Why should I not have infinite nines, right? The answer is that every 9 is additionally costly, right? And indeed, we see this in Australia with NBN, right? That sure, we could spend trillions of dollars putting dozens of satellites into space in order to fulfill 99.99999% population coverage. Or we could put 2 satellites into space and say, you know what, we're covering 4 nines of the population. That's good enough, right? There is a cost to each incremental failure that you prevent, and an incremental benefit associated with that individual failure that was prevented. At some point, those 2 lines cross over. So it's up to you to figure out how critical is this service, and then decide, okay, what is the level of reliability that we're aiming for, and what's going to be cost effective? Now, what do I do with this service level objective, right? All of this is abstract, right? Setting goals. Why do these goals matter? How do they make my life easier as an operations engineer? Let me tell you why. The answer is going back to that first point I made about operationally overloaded engineers. Often, when you get paged at 2 a.m., there's no actual end user impact. It's just something paging you because the disk usage got to 90.1%. 90.01%. Oh no, such an emergency, right? Were any users impacted? No. Was this worth waking someone up for? No. So we can instead think about using our measurements of what the reliability level experienced by our customers is, and use that to decide, is this important enough or not to wake a human up? So for instance, let's talk about the idea of the error budget, which is the inverse of your service level objective. If I'm targeting 99.9% reliability, that means 1 in 1,000 requests are allowed to fail. So if I'm serving 10 million requests per month, that means 10,000 requests per month can fail. And I can have a different degree of urgency based off of the error rate. Right? It's no longer an emergency if 1 out of 1 requests fails at 2 a.m. Right? Instead, I ask, if I continue having this number of errors, how many hours will it be until I run out? If I'm serving 1,000 bad requests per hour, and I'm allowed to have 10,000 bad requests per month, I'm going to run out in 10 hours. That's probably worth waking someone up for. But if I'm only going to run out in days, it can wait until the next business day. It's okay. And the beauty of this is that it catches subtle failures as well that are not entirely up or down. Here's an example of an actual failure that we encountered at Honeycomb when we were first turning on service level objectives for our own services. We started having an intermittent brownout where 2% of our traffic would fail for 20 minutes at a time, repeating every 3 hours. Now, it turns out that there was a memory leak and all of our servers had started up at the same time and were crashing and stampeding at the same time, but we didn't know that at the time. But what we did know was that our service level objective fired, saying that too many users were experiencing problems uploading their telemetry to Honeycomb. Whereas our conventional black box alerts were not able to catch the issue because of the fact that they wait for 2 consecutive probes in a row to fail, and we did not have 2 consecutive probe failures in a row. So besides making your alerting much higher fidelity, the other thing that service level objectives do is that they help you navigate the tension between product development and reliability. Instead of having product managers saying, ship more features, I want more features, right? Like, now you have a framework to treat reliability as a product feature. So for instance, if you're having too much reliability, that can almost be a bad thing because people's expectations will ratchet up. And your competitors might be innovating faster than you if you're focusing on delivering reliability at the expense of product features. So you might decide, I'm going to do an experiment, and I'm going to roll something out to 1% or 2% or 5% of my users, knowing that even if it fails 100% of 5% of users, you can roll it back within 5 minutes, and you're not going to damage that many people's experiences. But conversely, if you had a set of really bad outages recently, you can think instead about how do we invest in more reliability? How do we make the business case, right? The answer is we're failing our objectives. Therefore, our customers are at risk of no longer trusting our service. No feature that we ship is going to matter unless we bring reliability back up to par. Now, you don't have to have super complex SLOs to start with. Even your load balancer logs are great because they help you understand what is it that your customers are experiencing from a neutral-ish point of view, right? It helps you measure what you can in order to deliver a better customer experience and actually put yourselves in the shoes of those users. And over time, you can iterate to make those SLOs better, right? Like you can start incorporating things like real user monitoring from your client devices, right? Like there are a million things you can do. But start by meeting your user needs. And then if users are having problems that your SLO isn't firing, you need to correct your SLO. So SLOs help you reduce alerting noise and really help you hone in only on what matters. But that's only half of the story to me. Why? Because we don't just need to focus on the issue of operator burnout. We also need to focus on restoring customer experience as quickly as possible when we do confirm that there's a genuine issue. So let's talk about how that works. Our outages are never exactly identical, right? That we always have, if we're doing our job as engineers, we're always going to have these new kinds of failures that are happening that we didn't anticipate. Because you wouldn't have written the bug in the first place if you knew it was going to break. So therefore, by definition, anything that goes wrong in production is going to be something unexpected. And not only that, it may be something that is challenging or hard to reproduce in staging because staging is not production. Right? Staging doesn't have the same scale, and it's a futile waste of money to make staging look like production. We have to be able to debug things as they're happening live in production rather than waiting weeks to reproduce them. And we have to avoid creating these silos between different tooling across different problem domains, services, environments, right? Like we have to be able to use the same tooling to very quickly iterate and understand what's happening. Now, the thing that I've discovered is that in my 15 years as a site reliability engineer, when we have an outage, when something goes bump in the middle of the night, the thing that takes the longest is figuring out what do we think is going wrong and how can we verify that as quickly as possible. That's what takes the most time. Or kind of going to fighter pilot school for a moment, right? Like there's this idea in fighter pilot school of orient, observe, decide, act, right? The OODA loop. So we have to think about how do we accelerate that orient and observe part as quickly as possible? How do we actually explore that data in order to ask new questions rather than just leafing through the existing dashboards that showed us the questions we thought to ask before? All of this is to say that our services must be observable. In control theory, observability is the ability to, based off of the outputs of a system, infer its inner state. But I prefer to, in the systems engineering context of computer systems, think about how do we ask and answer unknown unknowns, things that we didn't anticipate would break in the first place. This requires us to be able to examine the events that are happening inside of our system in their full context, to understand properties like, which request is this from? This happens to be some of the innards of our query engine. And we can understand things like, for this query, which service issued it? Was it an end user? Was it our alerting service? And where did it get slow, right? Did it get slow waiting on AWS Lambda? Did it get slow reading files off of disk? Was it blocked on CPU? And which user is it, right? Like not just kind of mushing all of our users together, but instead thinking about how can we break apart and understand the behavior of each individual user in isolation. We have to be able to explain the variance. We have to be able to understand what separates a good user experience, right, a succeeding SLI, from a bad user experience, a failing SLI. So for instance, this is one way that you might visualize this data, right, to look at how can I see what dimensions are different between the succeeding and failing requests. But even better yet, why should we have to do this at 2 a.m. when we're at our worst? I do not think that we should need to be doing debugging at 2 a.m. It's about mitigating impact first. As long as you're collecting enough telemetry along the way, and you don't have to catch it live in the act, then you can roll back the bad release, drain the bad data center, and then you can debug it sitting cup of coffee in hand at 9 a.m. instead. I think that's a lot better. But to me, observability is not just a benefit to the break fix. It's not just a benefit to ops. It's a benefit to everyone. Because observability helps us gain better confidence in what our code's doing in the first place. Why are our tests failing? Or why is it that our deployment loop is taking 2 hours to run where it previously took 30 minutes? Or what are these users actually doing with these features that we released last Monday? Which users are making the most use of those features? And do I have any single points of failure in my system or circular dependencies that I should be working to fix over the longer term? Those are all use cases that I think everyone can benefit from, not just the people who are on call. The other misconception that I often hear is that observability is logs, traces, and metrics, that it's kind of these 3 pillars. And that's not true to me. Observability, as I described, is a capability. It is, in fact, a socio-technical capability. It's one where the humans have to be able to use the tools appropriately to be able to answer their own questions. And that means that it should be as easy to add the necessary debugging and instrumentation as it is to add a printf debug line. Because as much as I have done a lot of printf debugging and got here before, that's not a scalable method for working in prod. How do we make it as easy to add good observability as it is to do a printf? How do we send that data and store it in an economical fashion? And finally, most importantly, can you actually query that data? If you cannot actually query that data and answer your unknown questions, you don't have observability, you just have a very expensive dev null. So hopefully this elucidates for you why SLOs and observability go together. Because SLOs help you understand when things have gone too wrong, and observability helps you piece together why, so that you can remediate the issue, and then finally deliver a lasting fix to it as soon as is convenient to you. But we need to talk about the two other elements of production excellence besides SLOs and observability. We need to talk about collaboration. Because the reality is that no individual human debugs and solves things alone. No individual human is on call for services 24/7, 365. That just is not sustainable anymore. People deserve to go on vacations. People deserve to retire, right? Like people might be out on sick leave because of COVID, right? We have to be able to allow that slack in our system. So how do we make it possible for everyone to collaborate and debug together? How do we raise every human being to the level of the best debugger on their team? And how do we make sure that information is not lost as we cross organizational gaps? We have to think about a broader set of users. We need to think about the customer support agent or the cloud provider as equal customers to our engineering teams as far as who is a client of our debugging. And are we working together? Have we practiced this at 3 p.m. and not at 3 a.m.? Are we doing game days, right? Are we doing disaster drills so that we work out those kinks rather than doing it live? And we need to make sure that we have, not service selfishness, right? Service ownership does not mean selfishness. We have to make sure that people understand that we are working together and that hoarding knowledge inside of your head, sure. Many of us have read the Bastard Operator from Hell, the BOFOH comics, right? But, that's not a model to follow, right? It's not okay to have your job security tied up in how much you alone know. A modern system is built up of people who are working together. My colleague Jessica Kerr calls this the idea of semathesy, the idea of learning systems that are learning together, made up of humans and machines that are trying to do better and to iterate and to work better together and build better tools over time. We have to be able to work together and lean on our teams, right? We have to be able to hand off on-call responsibilities. We have to recognize that on-call is a team-level responsibility, not an individual-level responsibility. If someone is a new parent and they're having sleepless nights because of their child, don't put them on call, right? Well, I do believe that every developer should have some exposure to production. It doesn't have to take the form of on-call. It can take the form of working tickets during normal business hours, right? It just involves some form of feedback loops that you are exposed to the consequences of the technical decisions of your team, regardless of whether it's during working hours or not. And we have to document things so that we're leaving, as my colleague Tanya Riley says, we're leaving cookies for our future self, not traps. We have to keep things organized and not just, have misleading documents that lead us astray, that have gotten out of date, but we have to at least have these common patterns, right, of what is this service for? How do I shut it off? How do I update it? What happens if this breaks, right? Those are kind of the key things that we need to remember. And we need to make sure that, you don't have that single person like Miles or myself, who has been that hero for ages and ages, right? We have to share that knowledge, and we have to make sure that people are able to collaborate and having common sources of data. One common source of data that I want to point out is OpenTelemetry, which is a vendor-neutral standard that is developed by end users and multiple vendors working together in order to make sure that when you produce observability data, that is a single source of truth that you can pipe to anywhere you like without experiencing lock-in. And that's really powerful because it means that you no longer have data that is tied to one specific platform that, for instance, no one else besides one team can access, or that, you lose your data if you wind up having to change providers, right? Like, having the shared understanding and ground truth about what's happening in our systems is really powerful. We also have to make sure that we're rewarding curiosity and teamwork, right? That instead of saying, hey, Jess, I can't believe you didn't know that, right? Like, do you think Jess is going to ask me another question after that? No, she's not. So instead we have to say things like, hey, thank you for asking the question. I'm sorry that the documentation wasn't clear. Let's work together to document that better so that no one else has to stumble into that again. So by rewarding curiosity and teamwork, that really creates a healthier culture of collaboration. But it's not just about collaborating with your current colleagues. It's also about collaborating with your present, past, and future self. That often, we pull up get blame, and get blame says, you know who that idiot was who wrote that code that crashed? Yeah, it was me. It was me again, right? So you have to leave yourself breadcrumbs and be kind to yourself, right? To make sure that you're documenting things for future you so that you're not cursing future you in the future. But be kind to yourself about it. But while I did say earlier that outages are not exactly the same, there are common patterns that we often see in outages, and it behooves us as engineers to think about closing feedback loops and eliminating some of the more common categories of outages. And we can think about employing risk analysis to help us become more proactive in approaching our failure cases. So I have out my window the Sydney Harbour Bridge, and let's suppose that there's been some lack of maintenance and cars are falling through the roadbed and the Sydney transport trains are falling through. It's no good, right? And also, we all know, especially in light of the volcanic activity, that at some point, we live along the Pacific Rim, the earthquake's going to happen, right? And finally, it's probably long past time that we took down the Christmas lighting on the Sydney Harbour Bridge, right? Which one of those three things do we address first? We fix the cars that are falling through the roadbed and the trains that are traveling along the tracks that are leading to nowhere, right? Like, we fix that first because it's having the highest, most critical impact on our users. So we need to think about what's the frequency and impact of a risk to users. Now let's move back from the physical world to the computer world. How many of you have that shudder down your spine when I say the MySQL database? Right? That is a single point of failure. And we know as systems engineers that the MySQL database is going to fail at some point in the next year, right? It's going to happen. You don't often have control over frequency, but what you do have control over is impact. So how can we make the MySQL database failing not take out everything? Well, you could shard the database, right? You could have it only take down 2% of users' data at a time if it goes out. You could decrease the amount of time that it takes to identify that it's a MySQL database. You could also decrease the amount of time that it takes to fail over, right? You could have a hot spare running instead of needing to restore from a backup, right? That cuts the time from 2 hours to restore the backup to 2 seconds before the watchdog notices and kicks things over to the replica, right? So think about what are the risks that are the most significant, what's happening with the highest impact, impacting the highest percentage of users and lasting the longest, and then trying to move that needle, trying to work on reducing those significant impacts. That doesn't mean you have to eliminate them entirely, but you can think about ways to mitigate the impacts that they're less bad. And how do I decide what's a bad risk, what's not acceptable? Well, the answer is we just defined a service level objective, right? So if you have a service level objective in mind, then that helps you figure out, okay, I'm allowed to have 10,000 bad requests per month. This one failure case, for instance, the MySQL database, is responsible for, in expectation, it's going to cause 5,000 failed requests per month. That's too high because that doesn't leave us enough room for our unknown unknowns, for things that we didn't think were going to happen. So right there, that's your business case for being proactive, for fixing those issues before they cause you to burn through your entire error budget. Because it's not possible to operate a sustainable error budget if that error budget is already filled with known things that are going to break. And finally, this also helps give you a framework for how to approach your retrospectives from incidents. Many of us, when we create retrospectives, kind of create this list of 10 things that would have prevented this specific outage, right? It's not the right way to think about it. Instead, think about what were the highest impact things that resulted in an outage or an outage similar to this being able to happen in the future, right? Pick those 1 or 2 most important things based off of the frequency and the blast radius. And those are the ones that you should actually fix. And you can put the other ones on a bug bash list or on a hack week list, right? Don't waste your precious production improvement time doing Chrome polishing. But I want to call out 2 things. First of all, that if you have a lack of observability, that is systematic risk. That if every outage was taking half an hour, 2 hours, 3 hours even for people to figure out what's even going on, what services are impacted, who's impacted, like what do we think is happening, right? Like that is time that your users are suffering. And if you shrink the amount of time that it takes to debug things, and no, we don't believe in the idea of mean time to recovery, but certainly, you can think about the number of dropped queries, right, as users are experiencing pain, as you're figuring out what's even going on, right? So better observability is something that impacts every item on that list of risks. And similarly, if you have a lack of collaboration, right, if I'd talked to the AV team just now and I'd said something like, can't believe this, get your shit together, how could this possibly, right, like, do you think that's going to make them work better? No, that's going to make them work worse, right? Like, being friendly, being supportive, right? Like, that's how you ensure that people report issues early, that people collaborate, that they're transparent. In 2018, Google Cloud had a large outage that impacted global networking for about 45 or 50 minutes. Do you know what caused that outage to be solved in 45 or 50 minutes and not 3 hours? The developer who had pushed the code change that had inadvertently tickled that outage, they raised their hand and they said, I think it might be my change and I'm already reverting it. Instead of cowering and being in fear and not speaking up for fear of being fired, right? Good collaboration decreases the amount of time that outages take. So you don't have to be a hero in order to have a system that is production excellent. You just have to follow this recipe of those 4 things. And I'm not just talking in the abstract. I'm talking about what I've learned from my time at Honeycomb. That we're today about 40, 50 engineers, but when I started, we were 10 engineers, right? And we're competing with companies that are 10 times our size. And we managed to pull it off only because of some of these factors of production excellence. Of feeling like we had the freedom to deploy on Fridays, to deploy confidently, but also to have the responsibility to look after changes after they go out. We do not push and run, right? Like, it's not safe to push at 6 p.m. and walk out the door and go get a beer, right? No matter what day of the week it is. On the other hand, if it's Friday morning, go ahead and push as long as you're going to be awake and around to look at it. So you can see here that we push up to 14 times per day. And we've done this all while traffic has gone up 3 to 5 times in a single year. COVID has been really interesting for our business because more things are moving online. We have had basically a tripling of the amount of write workload, of the amount of telemetry data coming from our customers into Honeycomb. And we've also had 3 times as many people who are asking us questions, right? People who are trying to understand the behavior of their systems. So we've had to add all of these features and scale out our system and keep it reliable at the same time. And how do we do that? Well, we defined our SLOs, we thought about our areas of risk, and then we designed experiments to validate that that risk was not there and to fix those risks if we found them. Right? That's how we approach this. So we actually practice SLOs at Honeycomb. And our SLOs reflect the user value that we provide. Remember when I said earlier that we're a observability provider, right? What that means fundamentally is we are a big data platform, right? We ingest telemetry in, for instance, open telemetry format. And we have to break apart that data and provide kind of almost an index on it so that it can be quickly retrieved and queried later. So therefore, our SLOs are shaped like those user journeys. That if you view the homepage 99.9% of the time, it should load quickly enough, within 250 milliseconds. But that it's okay for some queries to fail, even up to 1% of arbitrary queries, that those could take longer than 10 seconds, right? Like, because the idea is you might be able to hit retry, right? That's okay. But the one thing that we do not muck around with is user data coming in, because we know we, in general, have like 1, maybe 2 chances to get it right if you happen to have a buffer and retry, right? That if we drop customer data on the floor, that's going to result in a graph, in a divot in the graph of every Honeycomb customer in perpetuity. So that means that we have to think about how do we adhere to such a high SLO, right? Right, that's 99.99%, that's 4.3 minutes of violation a month. That can be really hairy. So how do we stay within SLO? The answer is the accelerated state of DevOps metrics, right? Which tell us that if you deploy on demand multiple times per day, it's safer to do that, right? no amount of QA checking is going to find these big giant issues, so it's better, almost like riding a bicycle. The faster you ride, to a degree, the more stable you are, because you kind of have that spinning gyroscope, right? That the quicker the feedback loop is between you pushing a change into main and it landing in production, the more likely it is that you'll remember what was going on and have context to figure out what's happening. And that if there is a problem, right, like you'll notice that the DORA metrics say that 15% of companies, or 15% of the changes pushed by elite companies can fail. That's okay. The thing that distinguishes them is that failures are not expensive, that they can roll back in minutes or at most an hour rather than days. So for us, it starts with lead time. We think about how do you actually take less than 3 hours from the time that you're sitting hands on keyboard writing the tests, making sure they pass, to having it running in production. And the answer is we keep the build time fast, less than 10 minutes per build. And every time it gets higher than that, we do some debugging to figure out why. We automatically push once an hour. And the reason for that is that we are trying to keep the number of commits per build artifact low, and again, to keep that lead time very low. And while it is true that, maybe 5% of the time our changes don't work exactly the way that we anticipated, we only have about 1 in 1,000 changes fail in a way that we cannot quickly remediate, right? That require actually doing a fix forward or a rollback rather than just doing a flag flip. And that means that we've optimized around that path of making things take as little time as possible to repair. So what this means is that in practice, we add instrumentation, right? We add OpenTelemetry spans as we write our code so that we can better understand that behavior both as we're coding, writing our tests, and also as it reaches production. We don't do kind of heavyweight, Selenium tests. We do DOM tests to kind of serialize and diff the DOM to make sure that it's good enough. And we make sure every major change has the ability to turn on and off so that we decouple a release from a deploy. And we really prioritize making those unit tests fast. As I said earlier, a build time, 10-minute or bust, right? And if it takes longer than that, we're doing some digging to figure out why. And also, human beings prioritize doing their reviews as quickly as possible so that people don't drop state on the floor and people are not blocking on each other. That doesn't mean you interrupt each other all the time, but I'll check once an hour to see whether there are code reviews waiting for me because I know that that's blocking someone from getting their work into production. But what we don't do is we don't kind of hold things in the holding pen forever, right? As soon as the tests are green, we merge. And not only do we merge, we push the latest green build once an hour. We automatically push through each of our environments in sequence. But we have the ability to stop, to kind of pull an andon cord to stop releases if we think that there's a problem. So that's kind of how we keep the assembly line of production changes rolling out. But the most important thing that we do is that we observe real customer behavior in production. That we have a set of environments, not just for customers to observe their data, but for us to observe what's happening inside production. How are customers experiencing Honeycomb? And are there any problems, right? For instance, how are people actually using the feature that we built? How fast is it? How performant is it? And we also have to be able to observe dog food. So of course we have a third environment for that because it's turtles all the way down. And that's how we have 40 engineers deploying 18 times per day. But it's not just kind of product deployment. We also have applied that same mentality to our infrastructure. So for instance, we think about using Terraform and Chef and kind of all these lovely tools to manage our Linux VMs every day. And we apply these approaches of continuous integration, right? So for instance, we use Terraform Cloud to automatically push the latest green build so that we can't drift out of sync. We use feature flags to handle things like, hey, if I'm behind, I can toggle a feature flag in Terraform to stand up a catch-up fleet automatically. And I can quarantine bad traffic that's causing crashes or that I want to profile just with a feature flag in our Terraform code. And that really helps make life a lot easier for us as people who are responsible for the platform, who are responsible for making it possible for the product to move fast and scale on top of our infrastructure. But we don't just design in the abstract, we actually validate, we actually test, are these things working correctly? So we experiment using our error budgets. Now, when we talk about chaos engineering, we're not just talking about embroiled chaos. We have a goal of the experiment in mind. What are we validating? And is there a stop button? Is there ability to pause or reset an experiment if it's causing a problem? So we'll use feature flags, for instance, to control this sort of thing. In the event of our persistent services, we have to do a lot of work in order to make sure that the persistence mechanisms work as we anticipate. Because about half of our microservices are stateless, but half are stateful, and we have to treat them as separate classes. Now, there's a lot been said in the past about kind of, chaos monkey of automatically restarting stateless servers. I'm not going to hone in on that too much. What I want to hone in on is our stateful workload, where we have to be able to tolerate things like a individual Kafka broker going away, or one of our indexing workers going away. We have to be able to validate that we are able to do deploys safely, that Amazon is able to terminate our instances without causing failures to our customers. So when we have these kind of long-running storage instances that need data integrity and consistency, how do we manage that? Well, the answer is we test these failover dances. We test the system to make sure that in practice it works as designed. For instance, if a Kafka broker is lost, are we able to successfully start reading or writing to the new leader and in the background replicate in a new Kafka broker? Or if we take out an indexing worker, is it able to replay successfully based off of a snapshot stored to S3 plus replaying off of Kafka? So we do experiments in production. So we restart one server, one service at a time, right? Controlled experiments. We're not restarting all 5 things at once. We're just trying to test one thing at a time to make sure at 3 p.m. and not 3 a.m. for 2 reasons. Number 1, all hands are on deck, right? Bugs are more shallow with more eyes. But also number 2, 2 p.m. at least in the US is our peak traffic time, right? If a failure happens during peak traffic, that's kind of the pessimal situation as far as, the amount of load on the system, and we want to verify we can always catch up and make progress, even under the most load. And we are monitoring to make sure that we are not damaging user experience, using our SLOs and SLIs. And we are using our observability infrastructure to debug, to understand if our experiment didn't go the way that we anticipated, why is that happening and how do we repair it? And we also need to make sure that we're not, dropping telemetry, right? Like that if we perform one of these experiments, this actually happened last week. A Kafka broker failed to come back correctly after being killed and restarted. And we didn't have the telemetry to tell us that the Kafka broker was missing. It didn't report itself as missing. And therefore, we didn't actually have telemetry to tell us that there was a problem. So that was a useful scenario for us to know that was a problem that we needed to fix. And then you verify your fixes, right? Like if something doesn't go according to plan, you got to keep doing the painful thing until it stops being painful. So for instance, taking out indexing workers, taking out Kafka brokers. Guess what? We do that once per week, right? We try to not keep things running forever so that we can validate that if things do go wrong, it's not been more than a week since our most recent failure test. Same thing with Zookeeper, right? Like we discovered, our Zookeeper coordinators we were only polling the first Zookeeper worker. And that if you took out the Zookeeper first worker, none of our alerts would run. So we fixed that, right? When you de-risk things with the design and automation, it makes it a lot easier to run a sustainable system that is not going to page you in the middle of the night. So we just have to continuously verify and keep on making sure that our system is working the way that we intend. And this doesn't have benefits just for reliability. It also has benefits for cost. Why? Because if you're allowed to tolerate failures more often, you can do things like adopt spot instances or preemptible instances, because you know that you can tolerate losing those stateless workers. Or, for instance, if you know that there's a well-managed process for replacing worker nodes, that means you can gradually and incrementally roll your fleet without fear of damaging user experience, including rolling out ARM64 architecture instances. This is almost an entire talk in itself, but I firmly believe that the future of solving climate change within the tech industry, at least, is by consuming less power per compute. And when you adopt ARM instances, you're playing a direct role in fighting the amount of carbon emissions that your services produce, as well as, of course, saving about 40 to 60% on your bill. But not every experiment is going to succeed, and that's okay, right? You can mitigate those risks. And it's just important to think about, how do I bound the risk to make it acceptable to do these experiments? How do I make it safe to do these things and design for reliability through my life cycle? How do I make the system excellent in production? So feature flags can help, kind of doing proactive risk experiments can help. But above all, I think kind of you have to ground yourself in the 4 things I said originally, right? SLOs, observability, collaboration, and risk management. If you do those things, you're going to be in a much better place. And always be prepared. Always expect the unexpected, because we're always working in the turbulent situations of production. Make experimentation routine, and you can, not so jokingly, talk about the idea of, oh, I'm just going to set a chaos monkey running loose on our fleet. You don't get there, from nothing. You have to do the groundwork. You have to do the preparation in order to get there. So we're all part of socio-technical systems, as customers, as engineers, and as stakeholders. Learn from your outages, invest appropriately in observability, and have those conversations about how we can improve our tools and improve ourselves and improve our processes in order to react better in the future. And yes, tools can help. Buy the right tools. Buy just the right amount of tools, right? It's almost like that author who said, eat food, not too much, mostly greens, right? I think that's true. That's true about our socio-technical systems too, right? Like, run your systems, buy some tools, buy the right tools, but above all else, focus on your culture first, and the rest will follow. So I implore you, think about, how do you measure your reliability levels? How do you actually debug? How do you actually understand what's happening in production? Do you have the ability to collaborate across teams? And are you actually investing time in closing that feedback loop and not just repeating the same outages over and over like Groundhog Day? So that's all that I have for you today, and I understand that we're a little bit behind schedule because of the AV issues, so I'm not going to delay you too long, but if you'd like a copy of these slides, go check out honeycomb.io/Liz. And also, I happen to be around Sydney at least for the next couple of months, so if you'd like to go for a walk in Hyde Park, I'll drop a link into the conference chat, and you can just book an hour with me, and I'd love to go walk around and meet some of you. Thanks. Cheers, everyone.
Thanks, Liz. That was really good. Again, another great speech that I was looking at the chat and everyone saying, "Oh, this is really hitting with a lot of people." Really good stuff. I especially like all those little illustrations you got. They're fantastic.
Yes, they're by the wonderful Emily Griffin at Emily with Curls. Highly encourage checking her out.
Excellent. Great. Anyway, so we're about to finish off this session. We're just coming up to the first break of the day. Sorry about all the delays there. We've still got a fair amount of time. Remember that the main sessions start at 10:45, and then the lunch break will be around 12:25, depending on when stuff finishes. The afternoon session starts at 1:30, and don't forget the conference close at 5:35, where you'll get to, cry and cheer and all that stuff. So please go and have fun, and we'll see you a little bit later on.